This is a tutorial video on how to flash your Subaru via open source using a Tactrix cable. So this is specific to using the Tactrix software, which is ECU flash. This is the Tactrix cable we'll be using. It's a 2.0. This works for either a 1.3, the older 1.3s, or a 2.0. So you can purchase these on our website or on Tactrix.com. Make sure it's a genuine one. There's a lot of counterfeits floating around on the internet. So the first thing that you want to do is download the software, and you can do that via Tactrix.com. And you want to download ECU Flash. Make sure you select the one that's for your particular operating system. We're using Windows 10 here, so we've already downloaded and installed that. Make sure you allow the permissions during the install process to allow the communication to happen for the vehicle pass-through device in Device Manager. The second thing that you're going to be doing is downloading a second piece of software from Romraider. So you can go to romraider.com/romraider/download, and you can download Romraider, the latest version here, which is as of May 28th. We're using a previous version on our computer here, but they all work very similar to one another. So you can download this, install it, and then you're pretty much ready to start reflashing your car. So the first thing that you want to do is just open up ECU Flash. Okay, it's going to bring up the software. You see the watermark there. So we'll go ahead and plug in the Tactrix cable into our OBD2 port. So we're working with a 2010 Subaru STI hatch. You can see the gauge cluster overlaid via webcam just in real time on this part of the screen here. So it should recognize what particular vehicle it's connected to, but you can select that here. So if you select this icon, it allows you to configure the vehicle type. So for the earlier bug-eye Subarus, you're going to need to select one of these two depending on your year. So these are for the 16-bit ECUs. You can see the 160K size, memory size here. You might need a test mode connector here, and you can purchase these online. You can use just a paper clip or some other means to jump the two wires to put the car in diagnostic mode, but these hook up underneath the dash, and they work for those particular years, and it's necessary to put the car in diagnostic mode, which allows you to read the files from the ECU. If you have a newer 32-bit ECU, which is a drive-by-wire Subaru, either an STI, a Forester XT, Legacy GT, or a Baja, you'd be selecting one of these two. Here, the 512 or the 1024K, depending on the year range. And these still communicate on the K-line protocol. All the newer vehicles, newer than 2007, are CAN-based communications. So this is the one we're going to be selecting here because we're dealing with a 2010 STI hatch. And you don't need anything special to put it in diagnostic mode. For the 2004 to 2006 range vehicles, there's a green connector that actually comes in the instrument panel harness of the vehicle that you just need to connect the two halves of the green connector underneath the dash near kind of the clutch pedal, and that will put the car in diagnostic mode. The timing of when you do that to when you turn the key on, so you can see when we cycle the key here, nothing's going to happen because the car doesn't know it's in diagnostic mode. It's only once we start communicating with it via ECU flash that it will. So we'll click select now that we have the 2007 plus CAN protocol selected. We just want to double check that it's recognizing our Tactrix cable. So if you bring up Device Manager, just by typing in Device Manager in the search bar, we can bring it up here, and we can see that it is, in fact, shown as a vehicle pass-through device. So this might show up as a COM port on older operating systems, but you can see here it says Tactrix Open Port 2.0. So that need to make sure that is showing up. When we disconnect the USB cable, you hear a sound coming from your desktop. You'll see that obviously has gone away. It's no longer there, the vehicle pass-through device. When we refresh, and it should come. So that's kind of step one when you're not connecting properly, is to disconnect and reconnect the Tactrix cable and ensure that you're getting it recognized in Device Manager. So now we want to go through the process of actually reading from the ECU. So this is a good first step to back up the stock ROM before you do any modifications. So we want to read from the ECU's flash memory. So you can see we still have the key on. It's going to prompt us to turn the key off as soon as the will pop up in front of us here. And it's going to say if your ignition is already on from a previous operation, press OK button to continue. We want to actually turn the ignition off, and we want to turn it on right before we click OK. So you'll see here in a second, I'm going to turn the key on, and within a second or so, I'm going to click OK, and it's going to go through the reading process of reading in the bin file from the ECU. And you're going to see the progress bar on the bottom of the screen here kind of highlighted. So good common practice, just put the cursor over the OK button and get ready to click the mouse. And then you're going to turn the key on and quickly click OK. Reading, you can see here we had an error. So we will try again. So read. This is good for the tutorial video here that we're able to see this. So we'll click OK and then quickly turn the key on, and you can see now it's reading. So the important thing is you want to click OK and turn the key on in very close proximity. Click OK first and then quickly turn the key on. And that's going to allow you to know that you had it in the diagnostic mode, because it's querying now the ECU and reading all the kernels from each of the individual memory addresses. So it's going to step through this progress bar here. Once it's done, you're going to see the map metadata come up over here. So I'll just drag this down a little bit so we can see a little bit better. Done reading, it's going to say interface is closed. It's stopped the communication between the two. So now we're not really communicating with the car. We can turn it off if we'd like. So now you can see everything showing up on the left. So if you get any error messages here, they're somewhat cryptic at sometimes, but generally it gives you, if you have the definitions correctly installed, and they should install automatically and be in the right directory when you install with default settings, ECU flash. But you can see here in the ROM, the first tab is just the ROM info, and it's going to show you the ECU ID is important. The internal ID is kind of how everything's designated if you're looking through online tutorials of how to, or I guess online databases of stock ROMs. But this kind of tells you that it's a Subaru STI manual transmission, 2010 model year. It's going to tell you the method in which you were communicating, and then this number AZ1G702I. That's an important internal ID to remember. Now we can just click on any of the maps here. You can see some of them are grayed out because I don't have the user level set to a point that it's allowing us to look at them. So target boost is one that probably everyone would most likely change. And this is showing in the unit system that we've had it installed in. And this is showing in PSI here. So we'll close that. We're going to, let's say we want to look at a different thing, target boost compensation. It doesn't allow us to click on that when we click on it. So what we want to do is change the user level. So if we click the settings gear icon here, we can change the user level by going to metadata, then user level. We want to make sure we are in advanced or developer, let's say. Sometimes the settings don't stick. Developer should allow you to do everything. So just re-click the setting, and then you can scroll through all of the different tables and metadata inside the bin file from the ECU. So this is a subset of everything. It's not everything that's there. It's whatever's defined in the definitions file. But this gives you control over everything that you probably would want to change. Okay, so a good practice is to save this. So just file, save ROM as, save it somewhere with a meaningful name. So SRF file format is okay. You can save it as a bin as well. They're both read natively in ECU Flash. So we'll save it to the desktop here, and we'll call it stock ROM. and then we might even put AZ1G702I. Click save. Okay, now we want to perform changes. You might email this file to your tuner and they might do e-tuning, which is a service we offer. And you make modifications to that file. You can actually open it up in Romraider now. So if we open up Romraider, we can see it only allows bin or hex format. So we want to save it in one of those two, not SRF. So we'll go back, File, Save ROM as. We're going to save it in bin format now. Click Save, save the file. We'll go back to Romraider, open it up, and we can see here that it shows up as stock ROM. We'll open it up. It might not have the ECU definition, so this is where you can rely on your tuner or an internet database to make sure you have the right definitions, but that is beyond what we're trying to discuss here. So we'll just click OK. What we really want to do in Romraider is log. Okay, so after we make changes, we'll save the map. We'll go through the flashing process right now to just show you how you write again to the ECU. So we read. Now that we have a file open, it ungrade all of these other buttons here. So this one is reflash ECU. Using bootloader mode. This one is just write currently loaded ROM. So whatever's displayed on the screen, whatever we have open here is what it's going to write, and we can also test write. And that's just going to in case you have some corrupt memory or you're worried that something might happen and it's not the compatible file to the hardware that's in the car, i.e. you don't have you're using a 16-bit WRX bin file on a 32-bit car. Obviously that's not going to work. So you want to make sure the files are compatible. So test writing is a good procedure. We'll just go ahead and file back to the ECU. So we're going to turn the key off again. We'll click OK and turn the key on quickly after. So 1, 2, 3. Yeah, the timing there wasn't 100%. So try that again. We're going to write. That we flick the key on and click OK, and it's going to go through writing, and the operation was completed successfully. So it might be prudent just to start the car quickly here. So you can see that the car started. Sometimes it's a little bit rough right prior to after the flashing process has happened, depending on if it's a 32-bit or sorry, 16 or 32-bit car. You can see here, obviously the car responds normally when we touch the gas. Okay, so now that we've read the file, saved the file, flashed the file, we might want to go and do a data log on a dyno or on the road, on a closed road, to read the file. So we'll go to Romraider logger, and this is where we can click logger, and it'll say car definitions file not found. Would you like to go online to download the latest definition file? You can click yes. Generally, the definitions are available upon download here. So you can go and you click here and it'll ask you for where the latest definitions file is right here on the link. You're going to save that to a directory and you're going to ensure that in the logger it's available in the right directory. So I've already had this configured, so you can see that I'm seeing live data here on the screen. So when I step on the gas, you can see the accelerator pedal position here. We can look at this in different ways. We can graph certain things instead of looking at a dashboard. So let's say we wanted to graph air fuel sensor in terms of AFR. So we can see here as I touch the gas how it's
kind of oscillating around stoichiometric. So once we want to do a data log, we might select all the parameters that we want. So we'll go back to dashboard here. And these are kind of a common set of parameters that you need to data log. So air fuel correction, AF learning. So this is short-term correction. This is basically closed loop. AF learning is the long-term adaptive. Right now there's 0. We have -3, -4% of air real-time closed loop air fuel correction. This is the air fuel sensor reading. So this is not the target. This is the actual air fuel ratio in read by the wideband, the downstream wideband. This is the accelerator pedal position, battery voltage. This is for secondary air cars. This is the amount of cold start injector air pump, not really relevant for a power tuning run. Coolant temperature is useful, and degrees Fahrenheit is what's shown here. Engine load and grams per rev. The 4-byte engine load is important. The data log. Engine speed obviously is probably the most important parameter. The estimated odometer miles for this particular car, that's a good thing to corroborate. The ECU has a stored mileage based on a whole bunch of different parameters that it's recording to kind of display the total vehicle health and the amount of accumulated miles. If it's a dual AVCS car, you want to log both the exhaust and intake AVCS degrees. So this is for left and right bank. So that would be 4 if it's dual AVCS. So that's quad cams that you want to log. So you can see if I touch the gas here, these values should change. So if they're not changing, they might not be exactly the same depending on the oil pressure and the obviously what engine load and RPM you're at, but that's important. Feedback knock correction, vitally important when doing power runs. Fine learning knock, this is basically the reactive knock control based on the knock sensor. Fine learning knock correction is basically the preemptive knock control based on previous learned parameters. Gear calculated based on RPM and speed. The ignition advance multiplier, because we just flashed the car, this has not had a chance to increase yet. So generally by default, most maps will have 0.5. And then as you go through some different loading, the ignition advance multiplier will determine the fuel octane rating and understand the knock sensitivity threshold of the fuel that's in the car. And this will slowly start to increment. So this might not be 1 right away. Depending on if it's a 16-bit or a 32-bit ECU, that number can range between 0 and 16, 16 being fully advanced timing in terms of knock control on that ignition advance multiplier. For a 16-bit ECU and for a 32-bit ECU, it's just a scalar between 0 and 1. Ignition timing, vitally important. Injector duty cycle, vitally important. Intake air temperature. We have both intake cam angles, the manifold relative pressure, which is showing vacuum now of negative 9.43 psi. That's basically your boost pressure in absolute sense. Mass airflow showing the MAF transfer function, taking the voltage from the MAF sensor and then transmitting it into a airflow value in grams per second. Wastegate duty cycle for power runs is important to understand the wastegate actuation. For drive-by-wire tuning, requested torque is really important. So you can see here as I apply throttle, it's requesting a different amount of torque from the engine. Roughness monitor on 4 cylinders is effectively, it's a misfire monitor. So you can see we haven't had any misfires yet. SI drive mode that we're in is intelligent, which is 3. If we go to sport sharp, that's 2. And sport mode is 1. So you can see that there. Throttle opening angle, you can see just because there's no idle air control valve, it's using the throttle to actually manipulate the idle. So as I slowly tip into the throttle, you should see that move. And then TGV positions on both banks. The motor wasn't in a cold start when this happened, so they both haven't moved. So that's the basic set of parameters that you want to log. You're going to click Start File Log to start the logging. You can also use the defrog switch. It's going to show logging to file here, and this button is going to have a red border, and it's going to actually start writing to a CSV file. So we'll stop that, and we'll see where that went. You can change that in the preferences here, but generally it goes to your desktop. So we'll refresh that. So we'll double check on where that went. Logger output location, Control O. So that actually went to C user's user. So we will open up that file directory. Probably just want to change that to desktop. So we'll say desktop, open. We'll log another file. And this is where it's logging user desktop, so whatever your username, and then this is what the timestamp is going to be, .csv, Romraider timestamp.csv. Click stop. I'll make sure that you adjust the logging location, and then now you can see here it's going to show up on your desktop. So when we go to your desktop, it's going to show up right here, and we can look through the data. You can email this back to your tuner, and they can make changes via the open source software and send you a revision file. So that is kind of an exhaustive, we'll shut the engine off here. That's an exhaustive description of how to flash your car, first of all, how to read the ROM, how to save the ROM, how to flash a new ROM. The making changes part, we offer that as a fee-for-service type thing, where we do base maps, custom tuning, dyno tuning, things like that on our website. But yeah, that gives you kind of an overview of the parameters you should be logging. Some of these will not apply depending on the vehicle that you're actually looking at. A lot of the newer or older vehicles only have single AVCS or no AVCS at all. Some of the drive-by-wire parameters are different. The newer cars have SI drive and secondary air pumps and TGVs. Some of that might not apply to your particular combination of modifications, but that gives you a general idea of how to do it. If you have any questions, feel free to reach out with an email, and we'd be happy to help you.